Thank you. I know it's getting toward the end of the conference, and I'm going to actually change a bit of direction of what we're going to talk about. We've had a lot of very interesting talks and discussions on both precision medicine and prevention. I would say both of those are really aimed at looking at how do you defeat the disease after it's actually started. What we're interested in is what I call causality of the disease and what we call accurate medicine. So how do we improve the actual diagnosis, understanding what the disease is, and try to stop it or understand where it's coming from before we try to tackle how to deal with it. By way of disclosure, IPQ Analytics is a consulting group that works internationally, but we also have a nonprofit, and I'll be talking about work that's coming from our nonprofit. It's focused on not femtech, but femhealth. And there's a significant difference between the two. And what we're going to be talking about is R&D, but that's really research and discovery. By way of short background, I worked on the original HER2 test before there was a drug, Herceptin, and my job was to figure out what to do with the test to get it approved. I was also global head of computational biology at Roche, and I was the director of a Department of Defense-sponsored breast cancer center jointly with Walter Reed, where we did everything from surgery back through oncology, genomics, proteomics, and informatics. And the talk and what I focus on are systems modeling and disease in women's health. What I mean by that, when we look at what we're doing in women's health, we're looking at the concept that we have to understand development as a background in women's health. Our focus is on two different areas, infant and maternal morbidity and mortality, with an emphasis on hypertensive disorders of pregnancy like preeclampsia. And then also, as I'll talk about today, a normal menopausal transition and how that leads to postmenopausal disease, in particular breast cancer, but also osteoporosis and cardiovascular disease. And we work with underserved populations, as I'll point out later. But the important thing that really ties this together is understanding that things that are happening here may not show up until here. And so we really have to understand how that background of development is really tied into understanding disease. I show this as the good news. We'll talk about the good, the bad, and the ugly for those of you who know Cliff. This is the good news. Breast cancer death rates have been dropping significantly. Women are living longer who have been diagnosed with breast cancer. The bad news is it's costing a lot of money. It's about $30 billion to do treatment that will blow up to about $70 billion before the end of this decade. So it's coming at a significant cost, but what's not usually talked about is this, the ugly. While this is going down, incidence is going up globally. And that's where prevention really needs to start to address the problem. And that's why we need to understand what the causal mechanisms are. And so that's really what we've been focused on, trying to understand why this is going up and how we can start to come up with better ways and places to address that biology, where it's coming from. We started this a number of years ago when I ran the breast center. This is the Gale risk model that comes from the National Cancer Institute. It's the most common model for breast risk that's available. Anyone can get on the internet and run the calculation. But one of the things I observed when we're looking at this is this. As you can imagine, has age and menarche and so on. I've done a poll since I was involved with this at the beginning, almost 20 years. And in that poll, I have never found a woman who volunteered to have a breast biopsy done who did not think she was at risk for breast cancer. It's just not a common practice. And as a result, we have a bias in this. This came from the SEER database that you heard referred to earlier. This is what you would get out of an AI/ML model running on the SEER data. It's statistically correct, but it's not actionable. And the problem with that is this is what we've been working with for a number of years. So one of the things we did with colleagues in Italy, in the Italian government, where we had access to the Italian population, is we decided to say, what can we do with just looking at physiological development and come up with a set of parameters that ideally a woman could answer sitting in a doctor's office without consulting a record, just to see what would happen. And what we did was, these are artificial parameters, and I'll show you how we've modified them. But what we asked was, yes, when did she go through puberty or menarche? When was her first pregnancy? But what we were interested in really was how regular and how many menstrual cycles did she go through in that time period? Because that's the exposure to estrogen. We then asked, how close together were your pregnancies? How many pregnancies did you have? And then how close was your last pregnancy to menopause or the start of perimenopause? Because in that process, you're down-regulating the estrogen response system, but the fetus produces a 15,000-fold excess of estrogen. And so now you're flooding a system that's down-regulating a process with an overabundance of a hormone. And so we did that simple set of information, which any woman could describe, and then we compared it in the Italian population to the Gale model. The Gale model's on the right, and you see what we can predict. And we didn't even include family history in that. And so that suggested, it didn't prove anything, but that there was information in physiologic development that could be applied to possibly giving us a better prediction capability than what we were dealing with to start with. And so while I had to put that away for other reasons, we've come back to that as part of what we're doing now with IPQ in the nonprofit side. We know in general that the breast cancer distribution almost globally, this is the Chinese population, occurs in that range where, just as a reminder, menopause is the exact occurrence of 12 months of no menstrual cycles. Perimenopause is the 7 to 10 year transition that takes place up until menopause. So we're talking about that entire transition period. And I always would remind my pharma colleagues, having been in pharma, we don't take that into consideration when we develop drugs, that a woman may be going through many other conditions, but in the background, she's also going through perimenopause. And that's going to not only affect everything that occurs with treatment and diagnosis, but they're also going to impact her perimenopause. So this is sort of, as I think we're starting to understand better now, an underserved population, but is still 51% of the world. So it's a large population group by pharma standards. The risk models that have been put out, we've modified the Gale model to something called the Tyrer-Cuzick model. But in general, all of these models have different parameters that it's a little hard to read here. Some of them refer to family history. Some of them refer to things like having a breast biopsy or a typical ductal hyperplasia diagnosis. But the most important things are that consistency in the models that are currently being used to refer back to that same parameter that has been carried over from that Gale model. What we've tried to do is a bit different. When we looked at how predictive any of those models were, our ROC curve for those still comes out about 0.61. And most people would acknowledge that 0.61 is not really a very effective predictor. And yet, at breast cancer meetings all the time, when I talk to people who are trying to develop treatments, that's the model they use for high-risk calculations, because it's the model that's been around for so long. This gives you a profile of some of the risk factors that have been identified over the years, again, from statistical analysis. I could similarly give you a list of the 62 menopausal symptoms that have been identified with the transition of menopause, perimenopause into menopause. The challenge that we have is we're constantly in our surveys and data collection collecting checklists. Have you had this symptom? Have you been exposed to this risk? The reality is we need to remember that disease and transitions are processes that occur over time. They're not instantaneous switches. And as a result, what's important is not just that you have been that exposed to that risk. When did it happen? What else happened with it? How long did it take place, and in what order did they occur? Now, those seem like simple questions, but they don't appear in any of the databases we've ever encountered. And I'll get to that in just a minute. But what it means is this: if we have 3 women progressing over time, what we've learned is gynecologists are not really well trained in understanding menopause and perimenopause. I think most of the women in the audience would probably acknowledge that what they do is they have networks of friends that they talk to get information. And the first thing you're going to ask is, have you experienced this? And the most common thing you're going to ask about is your hot flashes. 80% of all women going through perimenopause have hot flashes. But what we're not understanding is that these women, 1 and 2, are actually on different trajectories through their perimenopause, where they will have hot flashes, but those hot flashes they have are not the same, because there's a process involved. There's other symptoms that have presented, and those symptoms actually should be considered like comorbid conditions, because they involve other processes and pathways in the physiology that are occurring at the same time. And so the fact that your best friend had hot flashes doesn't mean what worked for her or didn't work for her is actually going to be applicable for you. And that's one of the challenges, because we don't have data on how women go through perimenopause. It just has never been collected. So what we've done is we've taken and reversed the process that AI and ML specialize in, which is data-driven modeling, looking for correlations and patterns in the data. And as I pointed out early, the data that's available is the data that's been collected based on a previous model. And what we're doing is saying, let's build a model and then see if the data exists. And so we built a model of this is a coarse image of the model, of how women progress developmentally. And we started to ask questions like this. We know that menarche is going down. The age of menarche is decreasing. I'll show you the data. The age of childbearing or first pregnancy is going up. We know in general that nulliparity is a risk factor for breast cancer. Most people think nulliparity means you've never had a child and never been pregnant, but that's actually not correct. Nulliparity means you've never had a live birth. If you look at what happens because of this, that means that this is a nulliparous period, and that's increasing now as we're seeing the risk or the incidence of breast cancer increasing. I'm not telling you that that's a cause, but I'm telling you it's something that in a model you would want to pursue to understand its relationship, just as I'll show you in a second why a detailed understanding of pregnancy history is also important. This just shows you the age of menarche decreasing over time. This shows you that it's not just in the US, it's globally that this is going down. This shows you that the age of childbirth is frequently approaching the start of perimenopause. It's very common nowadays. And that maternal age at first birth is also going up. Now, in the model I showed you, the emphasis we had, let me go back quickly, has been on the mother as I described it. We also have to understand these are the stages of breast development during fetal development. That means there are things going on in the fetus that are due to exposure from the mother that may have an imprint that doesn't get expressed until they're much older. And so while we're not focused on that immediately, this is the kind of information we're now going to collect by actually modeling what's going on during gestation. This is an important slide to show you and the follow-up. We know the hormonal changes that occur during pregnancy. There are many hormonal changes, and any of you who've been pregnant, I'm sure could comment on that multiple times. But look at this. These are the key hormones that are produced by the fetus and the mother. And in a normal pregnancy where you expect a 38 to 40 week gestation, but you may deliver prematurely, you can see hormonal exposure could be as low as 50% in either of those two hormonal classes. We don't know what the impact of that is on the mother, on the fetus, or on her menopause, because again, we haven't collected the data. So what we've tried to do is build models now where these factors come into play and go and look to see where there's data, as was touched on earlier today. What we find is this database, which is the US NIH All of Us database, has a lot of information about gestational age at time of delivery, but no longitudinal data about the mother or the child. So the databases that we're accessing, the UK database, Biobank, the longitudinal Australian Women's database, even the Nordic databases, they've been designed for very specific use. I don't know about the South African databases, but they've been designed for very specific use to address very specific questions and don't allow us to actually build the models we would like to be able to build because we're restricted by the data that's present, and that's where the AI/ML becomes somewhat limiting. And so what we've actually done now is analyze that data, and just so you have a reference point, we started in that database with over 250,000 women. And by the time we refined that to be able to even address the question we were asking, we were down to 250 women. So we lost almost 95% or more of all the data that's been collected. That's not to say the database isn't valuable. It's just to say it's going to limit what you can do with the analysis. This shows you, even with that data, that we can still, in this population, show the significance of being able to predict breast cancer. But what we're really looking to do is go beyond that. Because say we look at that null parity period, and we identify that that has a significant correlation, analysis, impact on breast cancer prediction. We are now going in, we're now going in and looking at the underlying molecular transitions that take place during that transition to menarche to understand which of these processes, because in tools that I'm not going to show you today, we can do qualitative reasoning about each of these biochemical underlying processes. Those are other tools that we're not talking about today, but they allow us to take advantage of the genomic data that's available, the metabolite data that's available, any of the other data that's available and being stored in these databases, or other databases where we patch these things together to try to get to a molecular level understanding of where and why these conditions are starting to present, how they present differently in different individuals, how women go through menopause differently, uniquely, individually, and how that actually results in an individualized risk for breast cancer, an individualized risk for cardiovascular disease, and osteoporosis. And what we're really trying to get to, again, that we can't get to in the SEER database, as I pointed out, is not just predicting that you have a risk for breast cancer, but what type of breast cancer, because they're not the same. And it's not going from luminal type A to luminal type B in a progression. We have differentiation of all of these conditions. They should be managed differently, and they probably have somewhat different courses of origin and progression that we should be able to try to tackle. So what we've done is we've actually created our own study. It's been launched now in the US. We're launching it shortly in Australia. Those are two of our main sites. And we're collecting data that doesn't exist in any of these databases. As I said, it's a nonprofit. We're not doing it to gain proprietary position in anything. We're collecting it to show that there is important information that we don't have access to that can actually take the femtech that's being developed and apply it more efficiently and effectively into femhealth than we're doing right now. It's not just a set of measuring hot flashes. It's not just a set of measuring body temperature or changes that we might want to detect, but it's understanding what they really mean in the course of these progressions. So in conclusion, any disease really, not just what we're talking about here, needs to move from correlation to causality, from what we call precision medicine to accurate medicine. The diagnosis of a disease is probably the least accurate thing in the practice of medicine that occurs right now, not because the physician doesn't want to come up with an accurate diagnosis, but they don't have the tools or the data, and they have to act in a very operational manner, sometimes because of reimbursement or guidelines or things of that nature. We want to enable the optimization of individualized and personalized care by understanding an individual's interaction of development with disease. This gives you the potential for early risk assessment and now talking about prevention much earlier than a vaccine would even be present. It supports more effective development of biomarkers because we're targeting the actual underlying cause of the condition. It supports clinical decision-making. The physician has a much better sense, I didn't go into it here either, in where you are in a disease. We take biomarkers for granted. HER2 fluctuates during the course of a breast cancer patient's progression. It may go up and it may go down. And so we need to understand the complexity of what that progression is. It enables identification of critical, clinically relevant targets. We had the reference to AlphaFold. AlphaFold is great at giving you a potential structure for a molecule for which you can develop a drug, but it ignores whether that molecule in the biology is actually the important target. And that's where it has a gap in its applicability. We want to improve the potential for success in drug development. We know drug development fails 90% of the time, and it's likely it fails because we haven't stratified the disease adequately, because that's not what pharma typically does. And the opportunity is we probably develop a lot of drugs that have potentially valuable target and value for a patient population, but we haven't adequately figured out how to define them, identify them, and evaluate the data in that manner. We want to move from statistically significant to the concept of actually actionable, because statistically significant is not something that I want to be how my treatment is based. I want to improve the potential for better patient management and outcome, which I think is the goal of everybody at this meeting, everybody in medical practice, and really everybody even in pharmaceutical research in the long run. And with that, I'll just list some of our collaborators. We work with Morehouse School of Medicine. We're working with 2 of the major African-American sororities with their international presence. Christiana Healthcare is really almost the entire state of Delaware. We're working with some groups in Australia. Sage Women's Health is helping us with the survey there. And National Research Council of Italy is who we did the original study with. And Dionysus Health is extending what we're doing with development and allowing us to also start to look at epigenetic events and external exposure to toxin in the environment to make it a much more complex and complete picture. So with that, I'll thank you, and I think we have time, maybe.
Yes. Thank you very much.
Yeah.
We have 5 minutes for questions, so.
Thank you for a great talk, a lot of thought-provoking points. You've raised a few different issues. I've got a question now. You mentioned the fact that having a few bits of information, for example, have you had hot flashes or not, and when did you begin having periods? When did you begin menopause? Is some information, but not enough to develop a comprehensive multi-parametric model for what might be causing a particular issue. But it seems to me that if you could have the entire population provide answers to hundreds of questions, you could maybe tease out some information, which people wouldn't want to do. But women with breast cancer, I think, might be more amenable to an extensive survey, maybe most of which would be irrelevant, but that you could then find some clusters of significant events and correlation of events or timing of events that would lead you to some, at least supposition. It's uncontrolled and it's after the fact. But what do you understand my question? What do you think?
Yeah, so to address your point, what we're doing with the survey, the study we've initiated, it's a 2-phase study. The first phase is a feasibility study where we're taking the model we've initiated, which doesn't have all the rigor we really want. If we want to go to real rigor and to give you an example, we've incorporated a question in the first phase about breastfeeding, but we also really need to incorporate information. When did your menstrual period start again after your delivery, after breastfeeding? So there's a degree of rigor that we're not including in the initial survey to allow us to get closer, and also because funding is not available for the scale of survey we really need to do yet, to show the feasibility of doing this extension so that we can then get the funding from the appropriate sources to do the real rigor that approximates what you're saying, but it's still going to be driven from models, not just give us all the information you can think of, which is a fishing expedition at this point.
Any other question? Oh, I have. So thank you very much for your talk. Well, we faced exactly the same as you're facing. Well, first of all, excellent. You think about what is happening with the premenopause, because I think that there is no data enough, and nobody look at that carefully. And probably, I think that probably you will find even more data that not just only for this, if not, for a lot of problems that women are facing throughout life and even through pregnancy. So I can imagine a lot of results there. The thing is, when we face exactly the same, we were kind of, I don't know how much you are in contact, as I said, with those patients that have been doing the survey, but we reduce the population. Let's say we have 10,000. Then we want a certain question that weren't, looking backwards the data that the different hospitals provide us with. So we say, okay, try to, how much of this we have in contact or we have at least email address or whatever, a way to contact them. So we were reduced to almost 3,000, yeah. And then asking them if they would like to, participate in this, that is no compulsory, it's just only. So we end up with 2,000 people. So we create this kind of question that we want to, each question is a variable for us in the matter of, for the algorithms and all that kind of thing. And then, we are doing that now. Okay, it's a pilot project, but with that, we will have enough result to say, look, this is important, so we create this system, this is the way, so can we, put there in the whole system, or at least in, I don't know, in a region, and then collect the data and blah, blah, blah. So I don't know if you could do something like that, or
Well, that's what I'm saying.
with
This
the
is
pilot.
This is the pilot,
All right,
and we are only asking questions
yeah.
that a woman should be able to address without having to go to records.
Ah,
And that's the key. We want a woman, regardless of whether she's in an academic setting, in a local physician setting, or in a rural setting, or even using an app on her phone, can answer these questions and show the value of adding that data into the model before we expose something that would require a much more detailed looking at the data.
I'm sorry, I misunderstood. I didn't know that the data you already have from before,
Yeah.
and then are the same people or a group of them that you contact again. So
And
you
then, yeah,
you
and
you
so then
feel
we
that.
can go back again,
All
yeah,
right, all right.
yeah.
Sorry, I
Yeah.
didn't understand
Yeah.
well. There is any other question that now? No. Well, thank you.